All right, so sorry about the technical problems. My name is Ben Paulus. I'm an affiliate at the lab. Um, we started doing data visualization because the lab has lots and lots and lots of data, and it wasn't necessarily shared with the public or our audiences very well. Um, Usually the method of sharing was to put an extremely large spreadsheet file online, which I learned when I started that Excel only takes spreadsheets up to 1 million lines, and some of our spreadsheets were larger than that. So we needed a better way to share information. um, so I got into data visualization as a result. And what I've learned over the years, I'm going to share some of my what I've learned with you all. I'm going to start with introduction and theory and talk about some of the tools and best practices. And then since we have enough time and my presentation is not that long, my plan is to, after I end my presentation, that you download the PDF of the slides, which has active links in it. And the links will take you to some of the tools that I think might be useful to know about if you want to learn about data viz. So starting with the introduction and theory, what is data visualization, or as we in the biz we call it data viz. Data viz is, in my opinion, it's storytelling. You're telling a story about your research, about your data. So when it comes time to create some kind of image or product of your research, you have to ask yourself, what is the story? What do I want to say with the data? And to do that, you have to be able to anticipate what the user wants to know from you, what they want to know from your data, and what you want to tell them from the data, which is a critical split, actually, which is another decision point. So if you tell too much detail, too much information, it can get in the way of telling the story. Of course, your story can't, you don't want it to be too simplified. So you have to accommodate, you have to find the right level of data for your visualizations or your presentations. The alternative is what I'm going to be calling the exploratory approach, where you're presenting data in a way that the user can use it as they see fit. That's kind of a choose your adventure approach. The user is able to use your data through an interactive tool to ask their own questions and tell their own stories. There's a surprisingly large amount of literature about data visualization. First, the basic questions are who, what, and how. Like, who is your audience? What do you want them to know, and how can you best reach them? There are a lot of different ways to reach people with visualizations, and we're going to be looking at a number of them. And the two splits, which I kind of knew already, but this book laid it out much more clearly. They describe the explanatory approach versus the exploratory approach. You either explain specific findings, or you let the audience explore, interrogating your data with their own questions. The first approach, explanatory, is where you want to tell a specific story. This is an example of a data viz I made on the concept of specific power, which is a wind turbine technical term, having to do with the relationship between the size of the unit and the size of the generator and the swept area of the rotor. So, it's not a well-known concept, and we wanted to make it a little more well-known because it was a trend in wind power technology. So I made this visualization that combined text, illustration, maps, and charts, all in a way to explain not only what the issue is, what the technology is, what the trend is over time, as you can see from the line charts at the top, and also how it is deployed in different parts of the country depending on different wind regimes, which is the map. Down at the bottom, and I used Tableau, which is a software program that I use a lot. Down at the bottom are these two filters where you can narrow in on certain time frame or certain specific power ratings of turbines and see where they're deployed in the country. So this is not really an exploratory approach. This is an explanatory approach. The user doesn't get to explore very much. They really just get to see how it is mostly, with a little bit of exploratory ability. In the exploratory approach, to me, the clearest example is the Energy Information Administration's electricity data browser, which probably many of you have seen. It's kind of a landmark of energy data in the US. The data browser has a vast amount of electricity sector data into it, and it's nice interface that allows you to select a number of those different data sets and also select to filter them by fuel type, sector, geography, trends over time, maps, columns, all kinds of options. It doesn't really tell one story. It tries to let you tell any story you want. And by the way, the title here, Electricity Data Browser, is a link. So in the PDF, which you can download in the chat, those are links to all of the things that I talk about, anything that's hyperlinked here. And after my presentation, we're going to use some of those links to do some activities. All right. So this is the ultimate exploratory tool. Another great source is sort of the great guru of data viz is Edward Tufte, who's a former professor at Princeton and Yale. And he's written a number of books on theory and practice of data viz. Really excellent books, actually excellent art books, just very interesting whether you want to learn how to do data viz or not. Some of the rules that he lays out are these as on the screen. You know, using standard units and scales within a figure, you don't want to mix scales and units. You want to be as simple as possible visually. He really hates clutter because it gets in the way of telling the story. So he says use the least amount of ink possible, basically. The data should be in context for whatever it is you're talking about. Color is a narrative element, and I'll talk about that later on. And using the right amount of data, and that's that value judgment I talked about. You don't want to give too much data because then it's too complicated, but you don't want to give insufficient data because then it just raises more questions. And most of all, the goal is to reveal the data, not to just make distortions or confusion, but to reveal what the data says in a story. So that's the basic theory. In this section, making effective choices, we're going to talk about some sort of best practices, especially around some of the most common forms of data visualization, charts and graphs, maps, and dashboards, which bring together a lot of elements. There are many charts and graphs, and I'm sure you're familiar with most of them, a lot of them. Actually, there are so many more. I'm sure there's some I'm not even familiar with, but this is a partial list. Most often we use, line charts, bar charts, pie charts, but there are many other clever ways to do data visualization, and they're increasingly built into some of the most common tools for creating charts. Charts and graphs can be multidimensional. They can have more than one element overlaid, but they can also range from, simple to more complicated. This is a fairly simple one showing, oh, I don't know, what is it? It doesn't matter. It's just one chart I pulled out. And the point that it's multidimensional is that it's a bar chart and a line graph with vertical columns for each. And you notice the color is tied to the column or to the axis on each side, which helps make it a little more simple. And it simply shows annual and cumulative. The bars are annual, the line is cumulative. So it's fairly straightforward, but it is multidimensional. It has more than one element to it. This is an example of a very multidimensional one from one of my colleagues at the lab. It has lots of things going on all at once. It's got two axes, two vertical axes with different metrics, capacity on the left and percentage on the right, or gigawatts on the left. The use of color to show different technologies under the stacked bar. This is new generation added. And then for the right axis, it has these lines going along with dots for each year. So the lines themselves are color coded. It basically became complicated enough that they added little descriptions pointing to the lines, which is an indication that you're sort of at the very limit of how much you can pack into a graph if you have to start pointing out the elements. The elements should most often explain themselves or be obvious. This is one where there's so much going on that it kind of needs these labels to clarify it. It does, it still tells a reasonably clear story, but it takes some time to chew on it to get the story. Color and texture are both narrative elements, as Tuft said earlier on. Color, I think these days, especially now that everything is in color. In the old days, newspapers would be in black and white, and you would have to deal with a lack of color. Nowadays, everything is color, everything is on a screen. So color is really the most prominent way to convey categorization. This is a list of generation capacity in the interconnection queue waiting to get on the grid. It's separated by region. These are all the different utility operating regions of the country. And each figure is has a timeline on it. So you can see the West, California, MISO have very large queues, have grown rapidly in recent years. And checking the color schemes, you can see that it's hybrid storage, standalone storage, and solar are the three dominant elements in most of these regions. So this chart tells you a lot, and the color is very important. You can see lots of yellow on here. That's the solar. You can see lots of blue on the top, and that's the battery storage. And it also tells you, of course, that the amount of capacity changes a lot by region. It does not tell you, however, that some regions are much, much larger than others. The West is many times larger geographically and energy demand-wise than ISO New England on the right. So it doesn't put it all in context, but it does convey a lot of information. This is another example from that same report about the interconnection queues, where they used texture as well as color. And another case where they needed to add a label to clarify what they were doing, which is sometimes a signal that maybe it's not the best choice. The hashed color bars here are the striped portion, they call it, indicates the capacity that's in a hybrid power plant of generation and storage. So the story is that that hybrid capacity is dominating, especially in the West and in CAISO in California. And the use of color here shows that what enters the queue in that year and then what the cumulative total is. So the use of color is pretty efficient. I'm not so sure about the textures, and I'll mention that in a minute. The comparing them side by side, you can see the difference. They're kind of telling this similar story. The one on the left is solar only with or without batteries. The one on the right is all generation technologies. So they tell slightly different stories, but they still break it up by region and time. So It's a similar approach. Color can be used in other ways as well. A common um, format is known as a heat map. A heat map is not necessarily a map, but it can be. It can also be a chart that simply where the color varies by the intensity of data. So on the left is Gas Buddy. It's a website that tracks gasoline prices. And the prices are color coded with different layers of intensity. The pop-up here is from a mouse over, which indicates the specific price for whatever you click on. On the right is the Texas power market, ERCOT. They do a heat map to show real-time prices, locational marginal prices in the Texas electricity market. You can see that the red areas the prices are very hot, very high, often due to congestion and high demand, usually probably during air conditioning periods or something. The blue areas show low prices, which means lack of demand relative to supply, a lack of congestion. So it gives a very quick image. And this is a real-time map they include on their website. Power traders use it, for example. So texture, to be honest, I'm not a huge fan of texture in most cases. It can be very messy. It can make things hard to read. It can even create optical illusions if you really get aggressive with it. The blue and green chart here is the one I mentioned before about the interconnection queue. It's a little difficult to me to tell where the striped portion and the non-striped portion start and finish because the green sort of bleeds up into the striped portion. So anyway, not my favorite. The example in the top right is an example of sort of gratuitous texture. There's no reason for this fill to have a texture at all. The color conveys most of the purpose. I think where it can be useful is when you show the difference between actual and forecast, like on the bottom right. If it's actual, it's solid, it's real. If it's forecast, it's striped, which means it's not as real, it's sort of conjectural. You know, the meaning conveyed by the stripes is in line with the meaning you're trying to get across. It can also be useful to show things that are in or out of a set, like this example of the interconnection queue bars. Whether it's hybrid or not is in a set. I think just maybe the shape of the texture was not the right choice. I think I might have also used it just a different color scheme, like a related color scheme, a light blue or a light green or something. So generally, be careful about texture is what I think. One of my favorite, this is the last chart, and it's kind of the most sophisticated, I think. It's known as a Sankey diagram. Lawrence Livermore Lab down south from us in Livermore, they keep a number of flowcharts, they call them, these Sankey diagrams. This diagram is very instructional to me. I remember learning about this for the first time and having my mind blown. It shows energy inputs on the left and energy services or rejected energy on the right, and it tells you how it gets from one to the other through electricity or different sectors. And the stunning conclusion everyone takes from this is the massive amount of rejected energy or wasted energy that comes from electric generation and transportation, especially. So it also tracks the total quadrillion BTU of energy demand, which is total energy for the whole country. And it's useful in illustrating how the difference between primary energy and end use energy, which is very important as we move from fossil fuels to renewable electricity. All right. Switching gears to maps. We have a few types of maps here, ranging from simple to multidimensional, just like with the bar charts, or the charts and graphs, I mean. This is a very simple map, shows air conditioning consumption, energy consumption per household. It's pretty simple. It shows that places that are hot tend to use more air conditioning than places that are not. So it's a fairly simple story. One thing I would say is there are probably too many labels on here. We don't really need to know to be told that this is the United States. I think we all know that. And the selection of cities is somewhat random as well. Um, I think it would be fine with or without any labels. But it's anyway, it tells a simple story. One thing that's lacking is a legend to tell you, what quantity of energy consumption there is. You just see that it's more in the south. Um, this is an example of a multi-dimensional map where you have more going on, where you have bar charts overlaid with the map. The base layer of the map has color coding to show different utility operating regions, RTOs and non-RTO regions. And then the bar charts show the amount of capacity in the interconnection queue in each of those regions. So you can see in the west, there's a lot of storage in the queue. Not and the queues are much larger in the west than in other parts of the country. MISO is seeing a lot of solar, for example, PJM solar and so on. So it's one thing that maybe could have cleaned up the clutter a little is that every single one of the bar charts has large numbers on their axis. You don't really need to repeat the number every single time, or the numbers can be much smaller, which would make it look a little cleaner. And then this example is very multi-dimensional. There's a lot going on in this map, also from my Berkeley Lab colleagues. There's the base layer showing utility operating areas. Those operating areas are color-coded according to data, which is the percentage of solar penetration as shown in the legend in the bottom right. So you can see that California has much higher solar penetration, that is percent of annual load, than other areas like SPP. Then on top of that base layer are all the dots. The dots are color-coded according to the capacity value, which is the value of the the value of the energy and of the capacity in terms of dollars per megawatt hour. So dark numbers have lower value. Yellowy, orangey colors have higher value. You can see that in places with the highest penetration, like California, which is dark blue in the base, you also get dark purple in the value. So the value declines when you have higher penetration levels. So that's the story of this one. That the color of the base is correlated with the color of the dots. And just one more detail, the size of the dots reflects the project size. Larger dots range up to over 500 megawatts, small dots down to 1 megawatt. So anyway, you can see again, there's a lot going on, just like that earlier multi-dimensional line and bar chart. There's a lot to study here. You can also combine maps and graphs, and we're heading toward the concept of the dashboard. But before we get to that, there's this example. This is also the example of solar value. This value map, multidimensional map, is again getting toward the limit of what you can get away with in a single static figure. If you add any more information, you'll lose people. So that's a good point to go to interactive data visualizations. So that's where I come in, because that's what I make, mostly using Tableau. Here's the interactive version of the solar value data. And again, that's a link on the PDF there. It shows a map and two related charts, a pie chart on the bottom right and a bubble chart, I guess you'd call it, on the bottom left. The bubble chart shows the range of values within each region. The size of the bubbles indicates the size of the project, although they're highly compressed because I thought the size was not as important. Um, and then the pie chart shows the allocation of megawatts and projects by region. So the map shows you exactly where the projects are, but the pie chart shows you the relative volume by region. Down the bottom right is a whole bunch of filters which allow the user to change the parameters for essentially all of the data points, all the data values. They can look at it by balancing area or by state. They can zoom in, or they can see the change over time on the very bottom there. They can change to see the energy value versus the capacity value or the total value in that top right button. And they can filter out projects according to values, energy, capacity, and total. So it's kind of a solution to the problem of having too much information for a single static chart, is to make it interactive so the user can essentially create the chart they want to see. And like I said, the link to that is in the PDF, and we'll have time later on to explore some of these. Let's see. Oh, sorry. So to me, the classic combination, and this is a chart that Edward Tufte made famous. This is a chart from depicting Napoleon's march on Moscow in 1812. It's a combination of a map. The underlying these bars is a map. You can see labels, rivers labeled, and cities and locations. The size of the bars indicates the size of the army as they marched from the river on the left end to Moscow on the right end. There were a number of battles along the way, and they lost size of the army. Then winter set in, and they abandoned Moscow and went back. And the bar kept getting smaller and smaller. And as winter hit in, and a lot of that was due to brutal cold weather. The chart at the bottom of the figure here is temperature, and the temperature is connected in time to the marching of the army. So you see as the temperature declines, the size of the army shrinks. There's just so much storytelling in this. It's really a pretty amazing chart. You can even see, for example, the river crossings result in large losses in the army. So there are a lot of individual stories embedded in this, as well as the overall story. And that's in Tufte's got a few books. I forget which one that's in, but anyway, his books, you can't recommend them enough. They're really interesting. So once you've started combining things, then it's time to think about whether you're up for a whole dashboard. EIA has started making dashboards, so you can make your own customized dashboards, which are very cool. They're especially useful for tracking progress or showing the current status of something. They are often connected to data that is automatically updated. It's called an API, or an application programming interface. By connecting to an API, the dashboard or the data viz will change as the data changes. So it's easy to keep it up to date. Dashboards don't have to be interactive. They are often static because it is an example of explanatory storytelling more than exploratory, perhaps. So, but it's convenient because you can see the interrelations between items if they're laid out correctly. And you can get all your information at the same time. Like this dashboard shows natural gas use in New England. It shows you how consumption changes over time. It shows you utilization rates and prices. So it's got everything you need all in one place. All right. So interactivity is where you don't have static figures, you have figures that change according to the actions of the viewer. using primarily by using filters. It's definitely takes some work to figure out how to use them. There are a number of tools we'll be talking about in a minute. But you have to start with the question of why is it a good idea? When do you want to use it? And how do you want to use it? Um, and just repeating myself, there are exploratory and explanatory issues about when, why, and how you would want to use interactivity. The key features of interactivity are filters, as we've talked about, where the user changes the parameters to see different aspects of the data. A mouse over, you're probably familiar with, even if you don't know the term. You simply move your cursor over something and something pops up, or you might click on it and more information pops up. That can give you additional information, detail about a specific part of a visualization, like a map, without needing to clutter up the figure itself. And interactivity can also help with data downloads. Tableau for sure, and many others allow you to download the data, the raw data you're looking at usually in a CSV format. Interactivity obviously is not good at all for print. You can't click on your newspaper. It's okay for presentations because the user can't use it during a presentation, just like right now, which is why we're giving you the PDF. But I can use it so I can show things to you. It's really best for online presentation where the viewer comes to your website and uses it themselves and has the time to spend to use the tool. And the real reason for why is that it allows for greater complexity of your storytelling. You can tell lots of stories instead of just one, as with a static figure. So more detail on the aspects of interactivity. One is the filters, which are really the key thing for me. This is on the right is one of my clients is Ava Community Energy, which is our local CCA here in the East Bay. I made this tool for them that compares the fuel cost of gasoline and electric vehicles. So you can use filters to select the fuel economy of your gas car and the gas prices, and there are links to where you can look up the current gas prices. And then in the top right, you can see you can set the fuel cost for electric vehicles. You pick the type of vehicle, the time of your charging, because we built in Ava's electricity rates, and they have TOU rates, time of use rates. They also have seasonal rates, summer and winter, and they have different products. Bright Choice and Renewable 100 are, the regular and the all renewable product. And all of those have different electricity rates. So because you can charge your vehicle at different times and different seasons, it will show you different costs for charging. And the results, I've kind of hidden it at the bottom here, but it shows you the different costs per mile, the cents per mile for your electric vehicle compared to a gasoline vehicle that you've selected at the top. So this is, again, using Tableau, and by using filters, it presents different results. So I'm a big fan of filters. Mouse overs, that's an example in the bottom center. This was a data viz I made for Lisa Schwartz on integrated distribution system planning. There's information for each of the states is conveyed through colors that show what type of planning they do. But if you use the mouse over, you can give them more information, like whether they have different requirements and how often they do their filing. Putting that information on the map would have been very cluttering, not really effective. You can also put it in a table, but then it's less visually appealing, and it's not summarizing as well as you could. Another aspect of interactivity is that you can use your filters and controls to affect both maps and charts at the same time. Some of the earlier examples do that. And you can have URL links in your data viz so people can link to different sources. And as I mentioned, you can have downloads. And the downloads can be data, but they can also be images or crosstabs. So people can, for example, affect a map to show just the things they want it to show, and then they can download that image. So it's very useful to be able to have that interactivity. All right. So we're going to do an overview of some of the tools, and I noticed there were comments in the chat, but now my chat function has disappeared. So I'm not sure.
It's okay. I'm tracking
You're
for
tracking? Okay,
questions.
great.
Yeah,
Thanks.
if anybody has questions at any time, you can raise your hand. We'll call on you to unmute you, or you can put your questions in the Q&A box or the chat.
Okay. Is there anything we should address right away?
Not now.
Okay, great. All right, thanks. Okay, so now I want to give an overview of some of the tools that are available. And as I mentioned, when I'm done with my presentation, we have any questions and discussion. My plan was that since we have until another 45 minutes remaining, I think, that we would basically have like a class time where you could use some of the tools, get yourself familiar with them, ask questions about how they work. So first, let me run through them, and then you can think about what you're most interested in.
And Ben, I also put in the chat that I think a good use of time is if folks had specific data sets or some story they were trying to tell through data, they could ask for your opinion on, what might be the best way to present it.
Yeah, that would be great.
All
Yep.
students.
Yeah, it'd be great if we're actually all in a classroom, but I guess we're in the virtual classroom here. So here are a set of 6 types of tools for analysis, for visualization, making maps, graphics, and photos, and also sources of where to get energy data. So first of all, the most common tool for analysis is, of course, Excel and Google Sheets, the imitator of Excel, spreadsheets. Excel has been around for a long, long time and has become highly evolved. I'm always amazed at how much more there is under the hood than I can keep track of. These figures here are just some of the charts you can make with Excel. They've really been adding to the options: sunburst, tree maps, combination charts, all kinds of things. So you can do a lot with Excel. You don't necessarily have to learn more complicated packages because Excel itself is pretty complicated at this point. There are endless numbers of tutorials, how-to videos, online classes, books, all kinds of things to teach you how to use all those endless features of Excel and spreadsheets. Some of you, however, may have evolved beyond that into coding languages like R and Python. Then there are plenty of statistical packages like SAS, SPSS. A lot of these things live on, or a lot of programming things live on a website called GitHub, basically where people share their coding, their programming, and learn from each other. You can also store things on there. I don't do any programming, so I know all of these things exist, but I haven't used SAS since I was in college 30 years ago. So maybe you use it more often than I do. I tend to use a lot of spreadsheets and a lot of Tableau. Then there are data viz creation tools, authoring tools. There's simple ones like Data Wrapper and Infogram. Data Wrapper you see a lot in newspapers, especially online. It's a very straightforward thing for making simple interactive charts and graphs. Infogram is basically a nicer looking version of Data Wrapper. It has nice colors and animations to it. And the medium level of complexity is where I would put Tableau. Tableau is a commercial program owned now by Salesforce, but they have a version called Tableau Public, which is free to use. The catch of Tableau Public is that all of your stuff is stored in a public way. It's on their Tableau Public cloud, and other people can look at your visualizations. They can't necessarily download your data unless you let them, but they can see everything you do. Since Berkeley Lab is a public entity, we are all public all the time. So it's fine with me. All of our stuff is public. But if you're, working for a business, they may not want that. So you have to sign up for the non-free version. Tableau is, it's full of menus and option and choices that are built in that you can learn how to manipulate. But you can also integrate programming languages, do commands in it, and you can integrate maps from other sources like Mapbox. It comes with a sort of basic kit of base maps, but you can add more by pulling them in from Mapbox and other sources. The Microsoft equivalent is called Power BI. I haven't used it much, but it looks a lot like Tableau. And then there are more complicated choices. Programming languages like R and Python, you can get data viz packages that go with them, like ggplot and plotly. A lot of these are open source, so they don't cost anything. And increasingly, all of these things are integrating artificial intelligence, AI. So that's a rapidly evolving space that I'm just now sort of starting to pay attention to. Um, Mapping tools, again, range from simple to complicated. The most simple ones we're all familiar with, like Google Maps. Google My Maps is a way for you to use Google Maps to create your own maps. You can put things on it, usually just pins, but you can create your own data sets, on Google Maps. Google Earth, likewise, is a more sophisticated, better looking version of it. And there are increasing amount of sort of plug-in programs into Google Maps and Google Earth that allow you to do more things. At the medium level is Tableau Public, which has basic mapping. And then other services that have been created, because at the complex level, GIS software has been around for a very long time, and it's always been, I myself kind of have to retrain myself how to use GIS every few years because I don't use it often enough. It's not very intuitive. It's fairly complicated. And I think there are a lot of medium level products have emerged because of that, like Felt and Mapbox. ArcGIS Online is this sort of great big, it's sort of like the Tableau Public where everyone's maps are available and you can use their maps and combine them in different ways without really knowing GIS very well at all. So there are a lot of, medium approaches where you don't actually have to dig into GIS completely. But if you do, QGIS is the open source version. ArcGIS is you can call it freemium version. There's a free version and then premium for more capabilities. With GIS, of course, you make your own maps using raw data, but you can also combine existing maps. A couple sources for mapping data. The EIA Energy Atlas has a lot going on, and the Department of Homeland Security has a site called the Homeland Infrastructure Foundation Level Data, HIFLD site. They have a few hundred different types of maps that are publicly available, including over 30 dealing with energy. And this one on the top right is an example. These are electric service territories in GIS format. So it hasn't been color coded in any way, which is why they all look blue. But you can import that into your GIS program and then tweak it as you see fit. So energy data sources, there's a lot going on. As I mentioned already, the electricity data browser from EIA. EIA has lots and lots and lots of data sets that are available for download or through access through an API. The Open Data is their API portal where you can connect your software to their data directly. EIA also offers Excel add-ins. You can put this add-in directly in your Excel software, and it creates direct access to EIA data and the Federal Reserve data. So you don't even have to go out to a different website and download things. It just sucks it right into your Excel, which is very cool. Um, and Excel or EIA has also been increasing the number of widgets that you can create on their site and then embed them into your own site um, on any number of their energy data points. The extended version of this is, a cross-government, a site called OpenEI, um, where data is crowdsourced from industry and government agencies. And I looked it up. They have 2,500 data sets with 3.9 petabytes of data. A petabyte is a lot of data, lots and lots of data. So OpenEI has anything you can possibly want, I think. International Energy Agency has been really upping their access to data sets. They have a chart library with over 6,000 charts on it ready for download, and a navigation tool that helps you find different data sets. There are a couple of private sector projects that I like. There is plenty of commercial activity in data and modeling, but these two I thought I'd highlight. The Public Utility Data Liberation Project is essentially an effort to make utility data more freely accessible. And then Grid Status is a commercial service, I think, but is building a way to track electricity markets in real time, basically pulling in all of the RTO data and other sources into a real-time dashboard. And those are both, well, Grid Status is sort of a freemium model that you can do a lot of fun stuff for free. PUDL is a sort of a data liberation army, I guess. I think they're all volunteers. I'm not sure. Anyway, my kind of wonks. Lastly, we're going to talk about sources for photos and illustrations. An important thing, you might need photos for presentations or for putting on a website or a report. It's easy to steal content because it's all online and you can copy and paste. But I really encourage people to use what's called Creative Commons licensing. Creative Commons is a status that the creator puts on their product that allows other people to use it freely, but maybe requiring some attribution or restricting the amount of editing that can be done to it. Creative Commons stuff, there's a lot of it on Flickr, which is a popular photo site. You can search by different licensing statuses on Flickr. The NREL has an image gallery on their site. And then there are a lot of websites that are image sites that are either free or paid. Pixabay and Unsplash are a couple. Wikimedia Commons is all free stuff under Creative Commons. And then there are plenty of paid sources like Shutterstock and Getty and so on. And increasingly, there is AI. And to create an example, I wanted to have a photo of American workers on an assembly line making heat pump water heaters. Here on the right, this is a website called ChatGPT. So I put in that prompt and it created this photo for me, which is reasonably good. The water heaters look a little small relative to the people, but not bad for a first try. And frankly, some topics like this are actually very difficult to find in Creative Commons. Pictures of appliances, there are not many. There are lots of pictures of wind turbines, not many pictures of appliances and things like that, the more obscure things. So AI can be useful in filling those gaps. Lastly, illustrations. You can, of course, make your own, and PowerPoint and Google Slides now have lots of graphics built in. This is a little screenshot on the top right. The current version of PowerPoint has a direct access to stock images and online pictures that are available for use. You can have icons as well as photos. Um, there are software tools like Canva and Corel Vector where you can make your own images, um, drawing programs essentially. Then there are free and freemium sources like Unsplash, where illustrations are available online. Those are essentially advertising for illustrators. So they'll give away a sample, and then you can hire them to make custom illustrations. Again, there's not a whole lot going on with energy, but there's a little bit. And then we're back in the world of AI image generators. Um, Bottom right is a prompt I put in. I wanted a color illustration of an oil tanker passing by an iceberg. And interestingly, it gave me an LNG tanker, which was fine. A very pretty picture. Um, so I can see why AI is valuable for certain things like illustrations. And one last technical detail. Um, you should remember that illustrations come in either vector or raster format. A vector format can be sized to any size you want without losing any quality. It's a set of mathematical formulas that describe the lines, so it's adjustable to any size. Raster is a collection of dots. So if you want to make it really big, the dots get grainy. So you have to be careful if you're using rasters like a PNG file or a JPEG file, that your ability to size it is going to be limited. Anyway, all right. So just to wrap it up here, these are a number of sources where you can learn more. My favorite online sources are listed here. Our World in Data is just a collection of data sets around the world about the world. So it's very interesting to just poke around in that. Gapminder is another project. They're famous for their bubble charts that show economic development or global development issues by country, and these bubble charts move around over time. Very interesting to see population trends and demographic trends and so on. The one chart at a time is a set of videos that talk about data viz theory, and they explain how to do things and how to best practices and so on. And then lastly, on Tableau Public, they have a viz of the day. Every day they highlight some product that someone has made. And then there are many books. Here are a few examples if you really want to get into it. So that's the presentation. This is my contact info if you want to get in touch with me or look at some of the tools that we've put on the EMP database. Not all of which are mine, but there are a lot here. The US wind turbine database, the PV database are on there that were built with the US Geological Survey, as well as other data viz and tools, software tools.
That was great, Ben.
Thank
Thank you. We have one question already in the Q&A box. And I would urge people to raise your hand to ask a question live or put your questions in the chat box or the Q&A box. I'll find it. So here's a question. What is your recommendation for how to learn how to use the different modeling tools that you just went through? Multi-part question. Would you recommend just an internet search or something else? So this is how to learn. And then also, do you have any advice for how to choose which tool to use other than based on their complexity?
Yeah. I'm more or less self-taught with Tableau. And to be honest, the things that are most useful are YouTube videos because you can put in extremely detailed questions, and some guy in India has made a little video explaining exactly that thing. So YouTube is a marvel for learning those little details. Some of the tools I cited, they really intended not to require any training, like Data Wrapper and Infogram. They're really very easy. They're limited, but they're super simple to use. Likewise with Excel, it's really YouTube. I mean, Microsoft has a number of help features on their website, but they're not always the best at explaining themselves, you know? Other people sometimes explain them better than they do.
Well, there are trainings.
Yeah, oh yeah, and there are all kinds of trainings. Yeah. Yeah. Um, so the next question was about how to pick the right tool for the job. Um, yeah, it kind of depends on what your end product is. I think probably the most common end product is a static figure for a report or a slide presentation or something. Um, Excel does a pretty good job at that, um, especially if it's, you know, bar chart, line chart. You know, that huge table, or the slide of all the different charts you can do, like donuts and bubbles and things. Those are cool, but they aren't always, um, you know, being cool can get in the way of being clear. So often the best choice is the most obvious choice, um, rather than the coolest looking choice. So even, you know, just using Excel to create basic bar charts, pie charts, line graphs is often the right solution, I think.
So let
Yeah.
me ask a follow-up. You mentioned that you use Tableau a lot.
Hmm.
And can you, maybe give us more insight into why?
Hmm. Yeah. So when we started doing this, I explored a lot of different tools and I debated whether I should learn how to code with R and Python and so I could use their plugins. And I found that there were, you know, this whole range of tools, and that the Tableau was sort of the middle ground that did not require coding experience, um, but did have a lot of power. You could do a lot of cool things with it, um, without having to learn how to code. So that's kind of how I ended up at Tableau, because it's sort of in the middle. And I'll be the first to admit I don't take full advantage of all of its power, because I'm usually just in a hurry to crank out the products and I don't have time to learn every single detail about it.
And did you
Um,
just learn this on your own? You didn't take a class or anything?
yeah, I took a couple short classes at the UC Berkeley has a sort of data lab, I think they call it. So I took a kind of intro to Tableau up there. Um, but mostly it's just learning it on myself and figuring it out and watching YouTube videos.
All right. We have a comment in the chat that says this individual learned Tableau in college and it makes very nice looking figures and it didn't take much time to learn.
Yeah.
We do have another question here. Folks who are on the webinar right now are primarily working or largely working in government, municipal utilities or public utility commissions, state energy offices, tribes. Um, and governments may require permission to
Mm.
access, especially download software on work laptops. Do you have any tips on how to, you work as an affiliate for, an academic for a university that's
Mhm.
operated by, state of California, but have you experienced any hurdles in accessing any of these? And I know you can go off on your own private computers to do it. So maybe you're not the best person to ask, but maybe this is where like peer sharing. Does
Mm.
anybody, I'm going to turn this back since Ben has an alternative. He can like just switch to his consulting laptop and do what he wants. Does anybody have anything they'd like to share in this regard who's on the call where they've wanted to download some kind of tool and had to go through some kind of process with your IT department? You can just raise your hand or just unmute yourself.
I've had to do that myself. So sorry, give me just a second. I'm getting
Mm.
a little bit of feedback.
Yeah, you sound fine to us.
All right, there we go. That should be better for me. Can you still hear me?
Yes.
Mhm.
Okay, great. Yeah, just working at Sacramento Municipal Utility District, we've got pretty strong IT measures in place. So if whenever I've run into a situation where you're entering a web address and it's blocked, typically I just have to submit a service ticket to IT, explain what my purpose is in doing it, and I've got to wait, of course, for IT to respond, maybe ask me some questions. It's, about what's intended with the use. What information am I sharing? What am I taking from that site, and what am I or what am I sending to a particular site? That's usually the kind of information I need to know. And, I'd say most of the time I get the needed consent. There may be a bit of a delay though. If you're in a pinch, it's kind of a pain.
Great. Thanks, Eric, for sharing.
Yeah.
We also have a comment in the chat. An individual who works at a municipal utility and had the same question. We've been recommended, the Excel add-ons have been recommended, but they have to go through IT. And so I think that's pretty much the case everywhere. Emily, did you want to share more?
Yeah, if I may, I was the one who mentioned Tableau and IT, and also had a question earlier. So first of all, thank you for your time. Yeah, we've had a couple instances here. I largely use Excel, and we've been asked like, hey, maybe these add-ons would be useful, but IT doesn't really let you do anything with your software without further permission. So it's pretty much what Eric was saying. You have to submit a ticket. Hopefully they'll get back to you, sometime soon. Sometimes it can take a while, unfortunately. It really depends, I imagine, on the infrastructure and, the institutions, how good their IT is in that case. I know that there's also cases, other IT related things where sometimes things are set to work at the start and later on they just stop working. So then sometimes you have to go back to IT, and that gets a little weird. But that's the main hurdle I've noticed. It's just time and relying on those other parties.
Great. Thanks, Emily, for sharing.
Yeah.
We have another question. Any tips or best practices for building colorblind friendly visualizations? I think that's really good pushback on your pro only use color. Because there are some individuals where the color is not really that helpful, perhaps.
Yeah. No, it's often built into software now. You can choose, colorblind friendly things, or they're just sort of your default choices.
Is that in Excel, Ben? If you're doing a bar chart in Excel, for example, is there an option?
I think so. I should check that. Honestly, I should pay more attention to that because I don't pay much attention to it. So I should, because I know a not insignificant number of people are colorblind. So it is a best practice to accommodate that for sure.
Emily says she has some experience. You want to pop back on, Emily?
Yeah, actually, it's something that I've considered, but it's largely due to my partner who has a lot more work in presentation. But what he'll do is he'll go into his accessibility settings on his computer, and he'll turn on different versions of color filters. Like you can turn on just black and white filters, or you can turn on, I forget the different kinds, but there's essentially built into your computer, there's settings that allow you to adjust depending on what kind of color blindness you have. So, or you can change the screen so that it highlights the contrast. But the idea is that if you change the color of your screen, you're able to see, like, if someone only sees with these colors, then what does it look like? But
Great.
I tried, if I like, for example, have two colors, I try to avoid using like red and green, for example. Or I think blue is also involved in there. It's something I'm still learning about, and my partner definitely knows more than I do. But I'd say, honestly, the accessibility settings are a good place to start if it's not built into your software already.
Great. Thanks so much, Emily. We have another question. Well, Nate, you're on screen, so why don't you go, and then I'll ask the question that's in the Q&A.
No, I just wanted to say that's really big brain, Emily. Thank you. That's a great thought. I just find the color brewers that are built in, they are better, but they're often kind of ugly. Like I know it sounds bad, but like I think I know people who don't like to use them because by default they don't like, they look super high contrast. So then they make your visualization not that nice looking. So there's a balance there for sure. But Emily, that's a great point about building out using high contrast testing in advance. So yeah, it's cool.
Great. All right, we have another question. This individual proposed developing a GIS dashboard for a state energy office where he works, but there were concerns about who would maintain, this is a great question, Who would maintain the database after his fellowship ends? Especially since no one else on the team has any experience with GIS or Tableau. Do you have any recommendations for tools or best practices to create dashboards that are easy to maintain and can be supported by others in the office so the dashboard doesn't end up unused?
Yeah. Yeah. Well, so this is where an API comes in. An API links directly to the data source. And
What does the API stand for?
there was what was it? Automated programming interface, I think. And like the owner of a database will set it up so that we'll have a portal so you can get access to its data. You can send commands in and it will pull data out. And the benefit of that is that the owner of the data keeps the data up to date. And then people with their tools accessing the data will see the most up-to-date data. Only one person is in charge of updating the information, right? However, if your organization is not sophisticated enough to set that all up or not inclined to it, we've done a kind of a simple workaround. We kind of made our own API with some of our data vises. Tableau can pull data from a Google spreadsheet, a Google Sheet. So Google Sheets can be a good source of information for an interactive data viz. It can be its own sort of DIY API.
And you can share that with anyone. That's what we,
Yeah.
for example, with the integrated distribution planning example that you showed
Yeah.
earlier.
Yep, exactly.
And
So
then
it's shared with anyone so that the team can update the data and it flows right through to the data viz. That's probably the most workable solution to that kind of situation.
That's great. Thanks. Anybody else want to chime in with their experience or have additional questions or comments? All right, so we just posted ArcGIS story maps.
Hi, everyone.
Oh, yeah.
This is Laura Ward.
Hey, Laura.
How are you? So thank you so much for the presentation. I'm currently using the one of the in my opinion is amazing. It's an amazing tool. I just send a link via chat. So if somebody here in the meeting is able to use that to like present all the projects that they are currently working on, I think it can be a very good opportunity to use it and to present the math and the data as we have been learning during this presentation. So.
Great.
Yeah,
Thanks so much, Laura.
Yeah, for sure.
Yeah, story maps can be, so ArcGIS initially was the GIS mapping system software. Story maps, I think if this is what you're talking about, you can create these very cool sort of scrolling websites. As you scroll down, some new data viz thing pops up and it might be interactive. They can be cool. I can also find them a little overwhelming. Sometimes there's just too much stuff. People get too enamored of the cool things you can do, and I lose the plot. So again, that's as with all of these. I personally like to keep it simple, use the cool features, but use them effectively and sparingly.
Great. All right. Last dibs for anyone? Questions, comments?
And actually, one other comment about ArcGIS is it's not story maps, but they also have, like I said, this sort of depository of maps that you can access, and you can mash up maps together. You can add your own data to an existing map and save it as your own. It's very useful to create, new GIS products without having to actually, create them yourself.
Great. All right, one last chance. Also, Ben put his contact information in the slides so you can download them and reach out to him if you have additional questions.
Yeah, and as I mentioned, the slide deck has links to all of those things, so you can go off to Infogram or EIA or whatever and explore those sources and
Great.
tools.
All right. Well, thanks everyone. Thanks, Ben. That was really helpful.
Great. Yeah, thank you.
All right. Goodbye.